MCQ 26, a very observation-based question based on the function group that's given to us. So X here is reacting with cold sodium hydroxide. So which of the following groups will react? Now, sodium hydroxide is a rather popular reagent that's really used quite extensively in both A as well as O level. So of its usage itself, the first normalized sodium hydroxide, we should be looking for a neutralization event. And this neutralization can actually happen at room temperature and pressure, so you don't really need the heat itself. It can work with phenols. It can also have an effect with carboxylic acid as well. There will be a neutralization. So if heat was actually provided, we can actually use aqueous sodium hydroxide, number one, for the nucleophilic substitution of halogen derivative. That will actually allow us to use alcohols. And as well, if heat is actually allowed, this can be used for the process of basic hydrolysis. So some of the items that can undergo basic hydrolysis will involve esters, it will involve amides, as well as the involvement of nitrile products. Now, the end results of esters hydrolysis will actually be, in this case, if it's sodium hydroxide, a sodium conjugate base, and alcohol. We're going to get same thing, a sodium conjugate base plus an amine. That's actually coming out here. And for nitrile, it will become also a sodium conjugate base. So again, sodium hydroxide is really quite important for you to differentiate whether is it going to be RTP or whether is it going to be heat. So something a little bit off tangent here is that if, let's say, the selected solvent is not aqueous but it's actually ethanolic, NaOH, this can actually be used for the elimination of halogen derivative products, and this will actually yield us alkene. Now again, if the halogen derivative products are considered to be asymmetric, we actually have to employ anti-Markovnikov rule, because that will give us two different kinds of alkene. Then we need to take note of who is major and minor depending on the number of R groups that's attached to it. More R groups, major, less R group, minor. So for cold NaOH pertaining to this question here, we're not going to be using nucleosub or basic hydrolysis. Again, if it's aqueous, we're not going to think of it as ethanolic. So the only consideration here is going to be its neutralization capabilities. So we should be looking at alcoholic OH group that's not going to have any form of neutralization, because the alcoholic OH is considered to have a destabilized conjugate base. Right? It will not be able to react with your sodium hydroxide alkali, but only with metals. The amide group itself will have no reaction because we need the heat for basic hydrolysis. And with phenolic OH, there should be a reaction of neutralization. Again, visually back on the diagram, for option 1, they are talking with reference to this alcohol group. Option 2, the amide group. And for option 3, the phenolic group that's over here. So this is the only one that have a neutralization. No for basic hydrolysis and no for neutralization of alcoholic OH. So the answer for this question is D.